Why are registers crucial for controlling microcontroller peripherals? Imagine trying to turn on a light or start a motor without a clear way to tell the hardware what to do. That's where registers come into play in microcontrollers. They act like control panels that tell hardware what to do and check how it's doing. Registers are special high-speed memory locations inside the microcontroller. They hold information about the status of peripherals and the commands needed to operate them. These peripherals include things like input-output pins, timers, communication modules, and analog-to-digital converters. When you want to turn on a LED connected to a general-purpose input-output pin, you write a specific value into a register that controls that pin. If you want to start a timer, you set bits in the timer control register. To check if data has been received over a communication protocol, like Universal Asynchronous Receiver Transmitter, you read the status register. Each bit in these registers has a specific meaning. For example, one bit might indicate whether a peripheral is enabled, while another shows if an event has occurred. Changing these bits changes how the peripheral behaves. Most microcontrollers use memory-mapped registers, meaning each register has a fixed address in the memory space. The CPU can access these addresses directly using simple read or write instructions. This makes controlling peripherals straightforward and fast. Instead of complex hardware wiring, the microcontroller uses software commands to manipulate these registers. This approach simplifies programming and makes the system more reliable. From an electrical engineering point of view, registers turn hardware signals into software-readable data. This allows precise control over how peripherals operate in real time. For example, controlling a motor's speed involves setting bits in a pulse width modulation register. Without registers, the CPU would lack a standardized way to manage hardware functions. Practically, registers are used to configure and control many functions. Setting the direction of a GPIO pin involves writing to a data direction register. Starting or stopping timers is done by writing to timer control registers. Managing communication protocols involves setting baud rates and enabling transmit or receive functions through specific registers. Reading sensor data from an analog to digital converter is done through data registers. In essence, registers are the bridge that connects software instructions to hardware actions. They make controlling peripherals efficient, reliable, and flexible. This control is vital for embedded systems where timing, resource management, and precise operations are needed. Without registers, managing hardware would be chaotic and much more complicated. They are the backbone of how microcontrollers interact with and control the world around them.